Welcome everyone. This video describes a quite simple test of the TerraScan machine learning capabilities. I will show the process and the result of my building classification using trained model. Note that in this case my workflow is simplified as much as possible. This test used open lidar data downloaded from the website of the Danish Climate Data Agency, 100 square kilometers. 1% of the data, 1 square kilometer, is classified, the square in the lower left corner, and it will be used to train model. The remaining 99% will be classified automatically using the trained model. I will cut out long calculations from the video and let's get started. In this test, I will process data using TerraSolid software on top of SpaceX platform. First, let's review the source data. I load the initial point cloud in TerraScan, and you can see that the whole dataset contains almost 2 billion points. Actually, it's too much to be loaded into my RAM at once, so I load every 10th point. Just to overview. The data is divided into blocks. 99 blocks have two classes, ground and high vegetation, and one block that will be used to train model has three classes: ground, building, red color, and object, purple color. Class object contains above ground features that are not classified as a building. There are two TerraScan project files. The train project refers to the classified block, and the apply one refers to remaining 99 blocks without building classification. I open the train project and load the train block. Set display mode as group plus intensity. The first step is to assign groups and separate objects from each other for classification. Open the pre-created macro . This macro includes steps for height above ground, normal vectors calculation, and group assignment. Since this project has just one block, I can run macro on loaded points. You can see the result. Let's evaluate it visually. Save point cloud and unload the data. Then I do the same for the apply project. Open project and run macro for all project blocks. I set a buffer 20 meters, set right or original option, and use TerraBatch to speed up processing. This macro is slightly different from the previous one because of different classes and projects. The task is complete. Now open some blocks to check how the macro worked and see assigned groups. The next step is to set model metrics, model parameters, and run training. I open the train project again and load the classified block. Go to menu group and choose the train model item. In this dialog, I choose both classes, building and object, set the limit to 2500 groups, and use the decision forest TerraScan algorithm. 25% of the objects will be used to check model accuracy. And click OK. Here you can choose model parameters manually and evaluate how they affect the recognition of objects belonging to different classes. But in this test, I will not add any parameters manually and just use the option to automatically search for optimal ones. Parameters have been found. Now it's possible to check their influence on class separation, object recognition, and probably make some changes to improve the model. But I just run model training using automatically found parameters without any manual changes. The classification result looks good on objects used for validation. So I save the model into a separate file. Before starting classification on the entire dataset, let's check how the model works on some block. Open the apply project, load some block, some random block, set display mode as a class to see the initial data and to see the result, and run classification using trained model. Set class 5, high vegetation as a source. Select model file, building TDF, and run classification. Let's check the result. Probably it's not ideal and may require some additional correction depending on your task. But you see that most objects are recognized correctly and classification time is very short. The final step of processing in my test is to run classification on all 99 unclassified blocks. For that, I create a simple one-step macro. Action is classify groups, and routine is using trained model. I use the same classification settings as before. Save macro. Let it be called classification. And run macro on the project. Select macro file, classification. In this case, I will not overwrite the initial data, but create a new copy. I create copy in the folder laser 04. I also use TerraBatch and buffer. Click OK to start macro execution. The process is over. Open the new created project in the laser 04 folder and check that everything went well. Just load any random blocks and see how the data is classified. To see an overview of the entire classified area, load all data, including train project from laser 03 folder, one block, and all blocks of classified apply project from laser 04 folder. As before, I load only every 10th point to fit my RAM. So here is the result of my quite simple test. For better presentation, I turn off vector elements. And turn off some classes, class high vegetation and class object. And in my opinion, it seems quite impressive. Based on this, I can say that currently TerraScan has a great AI functionality, great AI tools for point cloud classification. And thanks for watching.